Hello guys, welcome back to the channel, and today we're going to solve this Leetcode question, which is intersection of two arrays. In this question we're basically given two integer arrays, nums1 and nums2, and we need to return the array of their intersection. Each element in the result must be unique, and you may return the result in any order. So basically we're given two arrays and we need to return the common elements in both the arrays, but they should be unique, right? They should be unique. Means there cannot be any duplicates in the result. So if you observe carefully, in this array and in these two arrays, there are two twos which are common, but we need to return only a single two, right? And in these two arrays, we see that 4 and 9 are common. So we need to return, we can also return 4 and 9, or we can also return 9 and 4. So when we look at the keyword unique, the first thing that comes to our mind is use a hash set, right? So a set is used to basically remove all the duplicates and store only the unique elements, right? So in the first approach, we'll use a hash set. So let's see how we are going to solve that. So initially, I'll take a set one. I'll take two sets. I'm sorry. The set one stores the unique elements of the first array, and the set two stores the unique elements of the second array, right? In the first array, what are the unique elements? 1, comma 2, right? And in the second array, what are the unique elements? There is only two, right? So after doing this, what I'll do is I'll traverse through the second set or the first set and check if the element is present in the first set or not. So I will traverse to the second set and I'll check if the same element is in the first set or not. If it is in the first set, then I will add it to my array. So let's suppose this is my resultant array. I'll be right here and I'll check if 2 is present in the set or not. It is present, right? So I will add this to my answer. And since this set does not contain any other values, that's it. Suppose if we have 3, if we also have 3 here, I'll check if 3 is present in this or not. This is not a 3, this is a bracket. This 3 is not present in this set, right? So I will not add this. And I cannot also add 1. Suppose what if there is also 1? 1. I'll check 1 is present in this or not. 1 is present, right? So this is the answer. So like this, we are going to solve this. So what is the time and space complexity? The time complexity will be, we'll be traversing through the whole first array, which will be, let's say the length of the first array is m, and the length of the second array is n. So it will be order of m. Plus we'll also traverse the entire second array, right? Order of n plus, and we'll again traverse the set 2, right? So the set 2 in the worst case can be order of n, right? So this will be our time complexity. And what is the space complexity? We're using a set for the first array, so at most there can be m elements, right? And in the second set there can be at most n elements, right? So this is our space complexity. And in the interview, the interviewer might ask us to optimize the solution. What we can do is we can use we can trade off between the storage and the time complexity, right? So in the second approach, what we can do is we can sort this array, we can sort the array and use two pointers approach. So let's take this example. So let's say this is our array, and we're going to use two pointers approach. So what I'll do is initially I'll sort these two. When I sort this, it will become 4, 5, and 9. And when I sort this, it will become 4, 4, 8, 9, 9, right? So what I'll do is I'll keep a I pointer here and I will keep a J pointer here. So this is my array 1, right? This is my array 2. So I will use a set in order to store unique elements, right? Unique common elements. So what I'll do is I'll check if my pointer, if my ith pointer pointing to the element and the jth pointer which is pointing to the element, if these two elements are equal or not. These two are equal, right? So it is an intersection. So I will add this to my set. Then I will move both the pointers at the same time since it is a common element, right? So I will move both the elements. It will become I and this will be J. Right? Now I'll check if these two elements are equal or not. These are not equal, right? So which pointer am I going to move? So if I move this pointer, which is pointing to 5, if I move this pointer, it will be pointing to 9, right? So when we move the pointer which is pointing to the highest element, there is no way that we're going to match with this, right? So we'll try to match this. Since this pointer is pointing to the smallest element, if we move the pointer which is pointing to the smallest element, then we can get a element which is just greater than this, and there may be a probability that it will be easy. It will be a it will be equal to this pointer, right? This element, right? So that's why we'll always try to move the smallest element. If we move the pointer which is pointing to the largest element, there is no point, right? These two will never be equal, right? So that's why I'm going to move this point. This will become J. Now I'll see that 5 and 8, these two are not equal. So which pointer am I going to move? If I move my 8, it will point to 9 and it will never be equal to 5, right? So that's why what I'll do is I'll move my smallest pointer. It will be I. So I will point here. And I see that again these two are not equal and my J is less than area of J is less than area of I, right? So I'll move this point. J. And 9 and 9 are equal, so I'll add these two and I'll move both the pointers at the same time. So my I will come here and my J will come here, right? So when one of the indexes goes out of range, then it is the end of the iteration, right? Then we'll stop and we'll just return the result. We'll create a new array and store these elements in the array and we'll return the answer, right? So that's what we're going to do. So initially what I'll do is I'll take a set hash set. So as I have already said, I'll sort both the arrays nums1, nums2, and I'll take two pointers I equals to 0, comma j equals to 0, and while I less than nums1 dot length and j less than nums2 dot length, if both nums1 of I is equals to nums2 of j, what I'll do is I'll add this to my set, right? Set dot add nums1 of I. I can also add a nums2 of j as well, but I'll always add the first one. And else if my nums1 of I less than nums of j, then I'll move my ith pointer. This is very similar to the thing that we did yesterday, right? In yesterday's problem. And at the end, I'll create a resultant array. The size of the set, and for every element in the set, I'll add it to my result. Then I'll just return my result. Try to sub again. time limit here. Oh, when we are adding both the elements, we just need to increment both the pointers. Forgot to do that. Yeah, let's try to submit this. Yeah, it's getting accepted, guys. And let's look at the time and space complexity. The time complexity for sorting the both the arrays will be order of n log n for the first array and order of m log m for the second array. We'll add these two, and the space complexity is order of n or m, right? Depending on the number of unique elements which will be present in the set. So that's it, guys, for this video. Thank you.